So I was talking about nuclear fusion. Okay, I was planning on joining the Navy as a nuclear engineer. I was going to get my bachelor's, uh, become a NUPOC in the Navy, work on an aircraft carrier, maybe research nuclear weaponry, nuclear fusion, and stuff. So I did some. I'm looking at nuclear fusion. Um, so from what I'm seeing, it's you have to reach ignition. So ignition is when the nuclear fusion reaction has enough energy to sustain itself. And I don't know if it just means that or if it also means that it is producing energy output that is usable. But anyways, it's sustaining itself. We want it to sustain itself and produce outputs that we can use. So so it takes energy to reach ignition. Um, okay, they're having issues with that from what I saw. Um, the issue is the magnetic field that contains the plasma, that the plasma is breaking through this magnetic, basically this magnetic force that they use as a container for the plasma. So just making that stronger. From what I saw, they have developed magnets. Okay, the college that I used to go to when I was there, I saw that, or maybe before I got there, I saw that they were like the leading or one of the leading universities on magnet research, like high-powered superconductors and stuff. So I think they might have been the ones that have developed this this new kind of magnet that can reach a certain Tesla, um, and actually be, it might solve the issue. So from what I saw, it's like there needs to be a 20 Tesla uniform magnetic container around the plasma. Right now they're using like 8 or something. These Florida State magnets can produce like almost 50 Tesla. So if you put a bunch of them around, you can have this uniform magnetic container that they're saying is required. So and then for the magnets, it's a superconductor. It has to be cooled almost to absolute zero. So you need these big refrigerators or whatever, like these cryo coolers. So the cryo coolers, the magnets, the magnetic field, the it needs to be hot. So it needs to be like 100 million degrees Celsius from what I'm seeing. So you may need to heat it. Like the pressure alone could heat it, but you may need to heat it as well. So if you can't get that much pressure. So heating it, they might use like lasers or something, microwaves, gamma rays. Now the amount of energy needed, it's said that the energy isn't the problem. Like the energy input needed to get ignition is not the issue. The issue was, like, the main issue was this, like, containing the plasma in the magnetic barrier. So with that might be, close to being fixed with these Florida State magnets. But so it said that like a power plant could produce enough power, like if you put a fusion power plant next to a normal power plant, that you could just get it to ignition, by using the normal power plant. It would supply enough power. That's what I was seeing. So it does produce radiation. Now it doesn't leave behind radioactive material. It shoots out neutrons, and you need shielding to protect from these neutrons being shot out. And once the reactor's turned off, like it said, it maybe a few minutes it'll keep being radioactive, but it'll stop. So you need shielding from the neutrons being shot out. They were saying like 12-inch thick, a 12-inch thick layer of lead around this plasma container might be enough. So okay, so you got shielding. You need the pressure, the heat, the shielding. You need the coolants for the magnets. Um, okay, the magnetic barrier needs to be strong enough. Okay, so like we might be close to actually getting it, and like being able to maintain it and use it and stuff. Now, things that it would be needed for, so large scale power, getting off of uranium, getting off of coal, getting off of fossil fuels, and then for things like, so we have electric vehicles, but there are some kinds of vehicles that you can't like use batteries for, or like solar stuff like that. So like airplanes, trucks, ships, trains. So you would need to fit fusion reactors onto these things, and you could like plug them into a terminal to get them to reach ignition, and then they can separate, and they've reached ignition, so they can maintain themselves as they go travel and stuff. For machinery and these transportation things and stuff. So it would need to, like, weight would be a factor. So we would need to be able to create these smaller fusion reactors within the weight constraints. So an airplane, like I was seeing that an airplane engine weighs like 5 tons. So if we can create a fusion reactor that weighs like 5 tons, we could replace it. A truck, I said a truck could withstand like a 5-ton thing or more. A ship could be like 50 to 100 tons or something, so bigger. A train, I don't know, but it probably could fit something like that. So like a truck or a airplane at least. So and then you need a certain megawatt output. Okay, so airplanes, it said, run on, like commercial airplanes run on 60 megawatt output. So yeah, you're going to need a certain megawatt output for these different applications. So the output, you would need the fusion reactor to have enough energy to sustain itself while producing the output aside from what it uses to sustain itself, necessary for the application. So like stuff like that. So the weight, the size needs to be correct. You need the shielding to protect people on board. So if these things were to shut off, now, it's not like there's a big meltdown like a nuclear fission thing, or like explosions and stuff. Like there may be explosions with fossil fuel applications and stuff. So it just like shuts down. From what I'm seeing, it'll just like shut off like pretty much instantly. So like if you're on a plane and it just shuts off, like you're gonna need safeguards. So a backup fossil fuel engine, which they already have, I think. Like on normal planes, they have the big engine, and then they have the backup engine that also runs on fuel. So just keeping that, and then the batteries for the controls and stuff, for the truck, something similar like that. Same with the other machines. So so we might be close to like being able to reach ignition on things, being able to overcome these constraints. If we get the big fusion reactor running, we can use that to start up the smaller ones, and we can create power grids and terminals to plug them into and stuff like that at like airports and trucking stations and shipping yards and train stations and stuff. We can have like terminals to get things to ignition and send them off. So getting off of fossil fuels may, but yeah, I can look more into that. I was just letting you know from what I saw. I was just talking to the AI about it. So I looked at how fusion is made, pressure, heat, They can do it with collisions, particle collisions. I looked at how, what is needed to produce these conditions, how to make it safe from the radiation, stuff like that, how to make it applicable to these different, these different needs. So